Hi everyone, Senan this side, and in this video we are going to see how do we solve this LeetCode daily problem, permutations in a string. So before we get started, I just want you guys to know that the whole PDF solution is provided in the description below, so that you don't have to check this or watch this video again and again. Also, this has my C++ code in it as well. So yeah, let's get started. So let's solve the LeetCode 567 permutation in a string. So given two strings S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. In other words, return true if one of S1's permutation is the substring of S2. So permutation is what? Permutation is a rearrangement of all characters of a string. Fine. And when you think about generating all substrings or generating all permutations, it's exponential, right? But we are not going to do that because that is something which is what? Which is exponential. But we are going to be a bit strategic and a bit smart. So let's look at some test cases and understand what we have to do. Okay, so S1 is AB and S2 is EID, BA, triple O. This is this, S2 is this is S1. Now the output is true. Why? Because a permutation of AB, which is either AB or BA, only two possible cases, and BA is present in this string S2. So S2 contains one permutation of S1 BA, so we return true. Now similar case, just that we have interchanged this BA and O. So in this case output is false because BA or AB, neither of them are present in this as a substring. Not a subsequence, but a substring. Substring is characters being contiguous, right? So B and in between we have an O, so that's not the case. Okay, some constraints. S1 dot length and S2 dot length is within this range, and S1 and S2 contains of lowercase English characters, only English letters. This is very important. This will actually allow us to make the solution a bit more simple. Okay, so what is a property of a permutation, right? So a property of permutation is what? The length of the both strings, or length of every permutation of string S1 is of the same length. That's the very first. Now, if they have the same characters and same frequency of all the characters in two, okay. So in other words, let's say we have S1 and S2, not to be confused with this. You have two strings and S1 and S2, and you need to figure out, are these two a permutation of each other? So how would you figure it out? The way you would do that is you would try to count every character in the string S1 with their frequency. Similarly, in S2, you'll count all the characters with its frequency, and you'll check if both the frequency of every character is same in both of these strings, so that is a permutation. Obviously, for it to be a permutation, the length has to be the same. So that is exactly the idea that we are going to use, right? Now, one other thing is that what is the approach that we are going to use? I just told you that if you go through some brute force approach, generating all permutation and trying to check that in string S2, that would be more than exponential, and we are not going to go that route. What we are going to do is use the idea of a sliding window. Now, since we know that the permutation of any string S1 is of the same length, so we know that our window size is exactly same for every iteration that we are going to do. So we are going to apply a sliding window, and in this case, since the length of string S1 is 2, a sliding window, or the size of the window in S2, is also 2. So what we are going to do is figure out the frequency of this A, and we'll basically figure out the frequency of all the characters in this window of size 2 and compare that with string S1, the frequency of characters of string S1. Similarly, after that, I'll try with this and check if this is a permutation of this. Similarly, I'll proceed through DB, and when I reach BA, I know this is a permutation of this S1 because the frequency of the characters in this window is exactly same as the frequency of this S1. And now, since I have seen one of the possible permutation, I return true. I don't even check anymore, because in other words, return true if one of S1's permutation is the substring of S2. So I need to find at least one. There could be more than one. Now in this case, I have a window size 2. I check this. It's not there. I check ID. Again, it's not there. I check DB. It's not a permutation. check PO, it's not a permutation. Check OA, it's not a permutation. I check AO, it's not a permutation. And I check OO, it's not a permutation. So in that case, since I've seen through the list, I return false because there is nothing to be done. Yep. So how do we keep track of the counts in the sliding window? Right. What I'll do is I'll initialize a sliding window for this. I don't want to redo the same operation again and again. So let's see how do we write this in code. First of all, I take n1 and n2, the sizes of the string, and if the size of s1 is greater than the size of s2, no permutation of s1 can actually exist in s2. So in that case, we return false directly. There's nothing to be done. Now I declare two vectors, count1 and count2, that is going to keep the frequency of the count2 will keep the frequency of the sliding window, the word inside the sliding window, and count1 would be keeping the frequency of characters in s1. Now what I do is I perform a for loop. I initialize the frequency map of the first window and the string itself. We just keep track of both of them. So that is why we are doing the same, because this would ensure us that the size of the window of s2 or this count2 is exactly the same of this s1. Now what I do is for I is equal to I less than s2 dot size. It's not s2, it's n2 and n1. We do the other way as well, but yep. So if while I is less than n2 minus n, why this? Because if I is greater than the opposite is true of this statement, then our final window size would actually be less than the length of s1. Quite straightforward. Now what I do is I say if count1 is equal to count2. So if I have a window which has the same frequency, I return true. And since you're comparing two vectors, it would be a linear time operation, right? So this is a linear time operation. But what is the length of that linear list? So I know the size of the list is 26 and both of them is 26 regardless of the size of s1 and s2. It's independent of the input. So it's saying it is as good as big O of 1 or big O of 26. So big O of 26 is what? Big O of 1. Now what I do is I see this, and initially, for example, I check this one. I have this and this in my count 1 and count 2. Now what I do is, since now I'm trying to update the window, right, to this one from EI to ID. So what I do, I remove this I from this frequency map. That is what I'm doing here, and then add this in our frequency map or list, whatever you want to call it. So that is what we are going to do. So what I do is just I remove this E and add this D. So this would keep track of the next window, frequency of the next window. So we don't have to recalculate the window all over again. So this is a big of 1 operation, this is a big of 1 operation, and this whole for loop is of big of 1 operation. Now what is the time and space complexity? The space complexity is what? The constant time, because I have exactly 52 variables to take care of at max for these two vectors. So this is constant space, not linear space, it's constant space. Regardless of the size of input, this is same. Now let's assume that this is what we are traversing for the first list. So which is what? This is n1, right? So I go through n1, which is size of s1, and then I go to n2 minus n1, right? So what is this? Is constant time, and approximately you could take this as constant time as sorry, this is linear time n1 and this is linear time n2. Now you could go through this exactly for what, n2 times. In the worst case it won't be that, it's n2 minus n1 and this is n1. So just in the worst case, let's assume that for n1 is 0, this would traverse the whole n2. So the time complexity is the size of n1 plus n2. Or if you want to be a bit more subtle, you'd say since this is going for exactly n1 size and this is for n2 minus n1 size, so you could say this, the whole for loop will go for big O of n2. n2 is what? Size of s2, right? And in the end, you just return this count. As we saw, that comparison is what? Comparison is constant time operation because the size is same. So yep, if I just submit this, this would be working fine. You see it's already accepted here. I don't know why I just repeated that. So yep, submitted, accepted, and yep, we are good to go. So yep, that was the whole video. And if you see the document that I've shared, the time complexity, I think I've written n1 plus n2. Yep, it's n1 plus n2, but you could say its size of n2 as well. So yep, that's all the video all about, and thanks for watching. Bye.